So here is we are having the next question, question number 21. Which of the following diode is reverse bias? We know that if the potential of P is at lower potential as compared to the potential of N side, then only the diode will be reverse bias. So since for reverse bias condition, P side must be at lower potential as compared to N side. So we have to check the options. In option 1, P is at high, N is at low. So that's why it is forward bias. In option 2, P is at 0 potential and N is at negative potential. So again, P is at high potential as compared to N. In option 3, P is at -2 volt and N is at -4 volt. So comparatively, P is at high potential, N is at low potential. So again, option number 3 is also forward bias condition. But in option number 4, P is at -3 volt potential. On the other hand, N is at -2 potential. So the potential of point P is lower in option 4 as compared to N. So that's why option number 4 will be in reverse bias condition. So that's why we will go with option number 4, which is absolutely correct. Here is question number 22. A PN junction diode is connected in parallel to 3 ohm resistance in the circuit as shown in figure. If the potential drop across the diode is 0.3 volt, then the current across 7 ohm resistance will be what? So we have to calculate this much current. The current actually drawn from the battery. Now the diode is at 0.3 volt. So 3 ohm will also have the same potential, 0.3 volt. The overall potential of the battery is 6.6 and 0.3 volt is dissipated right here. So the left is, or you can say, potential drop across 7 ohm resistance will be V equals 6.6 minus 0.3 volt. That is 6.3 volt. The resistance given, that is 7 ohm. Therefore, the current across 7 ohm resistor will be voltage 6.3 upon resistance, which comes 0.9 ampere. So after looking at the answer, we will choose option number 3, which is absolutely correct. So therefore, we will go with option number 3. Now let us proceed to the next question, that is question number 23. So here is question number 23. A rectifier circuit along with input is shown in figure. The output waveform across RL will be given by. Consider diodes as ideal. Now this is the circuit for full wave center tap rectifier under the positive or first half cycle. During positive half cycle of the input, diode number 1 will conduct, D1 conduct, and therefore you will get the output across RL. Now during the negative half cycle, diode D1 will be reverse biased, so that's why it will be open circuit. But on the other hand, diode D2 will be forward bias. So that's why diode D2 will conduct, and again you will get the output across RL this way. So this is the circuit or the full wave rectifier, and you will get the output always in same direction. And after looking at the options, we can say that we will get option number 1. Now let us proceed to the next question, that is question number 24. So here is question number 24. The current gain of common base NPN transistor is 0.96 if it is used as common emitter amplifier output resistance 4000 ohm and input resistance 1000 ohm, then voltage gain of the amplifier will be what? Now we know that the voltage gain for common emitter amplifier AV is written as beta times output resistance divided by input resistance. Here it is common base configuration. So in common base configuration, current gain is written as alpha, which is given 0.96. We can calculate beta with the help of alpha, that is alpha 1 minus alpha. So put the value in AV expression. AV equals alpha upon 1 minus alpha multiplied by output resistance is 4000, input resistance is 1000. Alpha 0.96 only. 1 minus 0.96 multiplied by 4 gets you finally 96. So the voltage gain will be 96. And after looking at the options, we can say that option number 2 is absolutely correct. So we will go with option number 2. Now let us proceed to the next question, that is question number 25. Here is question number 25. The IV characteristic of a photodiode will be what? You are having 4 options. We know very well that the photodiode works in reverse bias condition. And if we increase the intensity, the number of photons will increase and hence the reverse saturation current increases. Since photodiode works in reverse biased condition and we increase intensity, number of photons increases. And therefore reverse saturation current also increases. Reverse saturation current also increases. So after looking at these things, we can say that option number 1 is absolutely correct. So that's why we will go with option number 1. Now let us proceed to the next question, that is question number 26.